Hello students, I am Professor NAVNEET from EC Department, SIRT College. Today I will be discussing Lab Experiment 1 of subject Digital Communication. In this lab experiment, we will do the Matlab code for natural sample signal. So the aim of the experiment is to write a Matlab program to observe naturally sample signal. Now the theory. Here, first thing, the sampling. Sampling is the process of converting analog signal into a discrete time signal. Now, there are two types of sampling, natural sampling and flat top sampling. Natural sampling is a practical method of sampling in which pulses have finite width equal to tau. Here, the message signal is multiplied with the train of pulses, which is represented as the carrier signal. Here, the amplitude of the pulses of the carrier signal varies according to the instantaneous amplitude of the message signal. In natural sampling, the top of the pulses follow the message signal. Now, this is the practical circuit for generating a natural sample signal. Here we can see the input. The input is message signal. This is a switch which is operated by a clock pulse, which is given as the carrier signal of frequency Ts of time period Ts, and Gt is the natural sample signal. When the pulse will go to high level, the switch will be closed and the message signal xt will be multiplied by the carrier signal ct, and we will get the natural sample pulse, which is represented as gt. But when the pulse will go low, the switch will be opened and the circuit will be open, and the message signal will no longer reach the output. So the output signal, which is natural sample signal, will be 0. So in this case, so we will get the train of pulses whose top will follow exactly the flow of the message signal. Now this is the spectrum of the natural sample signal, which is given by A tau by Ts summation sinc function nfs tau and capital X f minus nfs, where xf is given by the spectrum of the message signal xt. Now this is the MATLAB code for generating the natural sample signal. Now whenever we want to represent or define any signal, the first thing is to define the parameter on which the signal is dependent. That here the independent parameter is t, which is given by the range 0 to 1 with an interval of 0.001. Now here we have two signals, message and carrier signal. So we have to define the frequencies of these two signals. Now in order to input the frequency of the message signal and carrier signal, we will use the command fm is equal to input enter the frequency of the message signal. When we enter this command, the code will ask the frequency of the message signal. Say the frequency is 5 Hz. Now for carrier frequency, fc is equal to input enter the frequency of the carrier signal. When we'll enter this command, it will ask enter the frequency of the carrier signal. Say the frequency is 50. Now, for defining message and carrier signal, I'll define its expression. Message signal is given by a sinusoid of frequency fm and amplitude 5. So Vm is given by 5 into sine 2 into pi into fm into t. Similarly, carrier signal is given by the square wave of frequency fc. So Vc is given by square 2 into pi into fc into t. Now for a carrier signal, we can see in this figure, we want a pulse signal. So here in this case, Vc is given by square signal. So we will convert the square signal into train of pulses. In square signal, we will see the the wave will go from high level +1 to low level -1. Whereas for generating pulses, there should be no negative value. The pulses should only go from 0 to high and come back to 0 level. So here, For generating a pulses from square signal, I'll use a loop for I is equal to 1 is to n, where n is given by length of Vc. Length of Vc means whatever is the number of the samples in VCR. Now, for I is equal to 1 is to n, that means I will take its value from 1 to n with an interval of 1. First, I will take value 1, then 2, then 3 till value of n. Now, if VCI is less than equal to 0, this means that the particular sample of VC, if it is less than equal to 0, then VC will have value 0. Else, that means if VCI is greater than 0, then in that case VCI will be end. Now I will terminate the loop, end and end. Now this means here that the negative levels are converted to 0 levels. So we will get a train of pulses instead of square signal. Now we have message signal as well as carrier signal. I want to generate a natural sample signal, and the natural sample signal is generated by multiplying message and carrier signal. So the natural sample signal is given by V, which is given by multiplication of Vc and Vn. Here we can see that there is a dot and star. Dot star is syntax is used, that means we want to multiply sample by sample of Vc and Vn. That means corresponding elements or samples of Vc and Vm will get multiplied with each other. Now this Y will represent the samples of the natural sample signal. Now we will plot all the three signals, which is message signal, carrier signal, and the natural sample signal. So for drawing all these three waveforms, I'll use command subplot 3, 1, 1. That means the figure window is divided into 3 rows and 1 column, and the first figure is located in the first position. Plot command is used T, VM, so message signal will be plotted. Now for labeling the waveform, I will use X label and Y label command, X label T and Y label VMT, and to make it more expressive, I will use the title message signal. Now the carrier signal will be plotted, which will be given by subplot 3, 1, 2. That means carrier signal will be located at the second position. Plot T, VC. Now for labeling it, X label T and Y label VCT, and the title will be given as title carrier signal. Now in the end, I will draw natural sample signal. Now natural sample signal will be located in the position 3 of the figure window. So the command which will be used will be subplot 3, 1, 3. Now the command will be plot T, Y. Now for labels, X label T and Y label will be YT, and the title will be natural sample signal. When I will run this Matlab code, I will get a figure window which will display all the three signals. Now we can see the first waveform is message signal, the second waveform is the carrier signal, and the third waveform is the natural sample signal. Here the samples are samples varies according to the instantaneous amplitude of the message signal, and the top of the samples pulses, they vary exactly according to the message signal. Now this is for today's lecture. This is experiment number 1. Thank you for